This is really awkward. I'm joining another Leetcode Weekly Contest. This is Weekly Contest 475. It ends in 30 minutes. I think due to daylight savings time, I actually was an hour late, so here we go. Minimum distance between 3 equal elements, and the constraints are very low in size, so it's brute forceable. Basically, you're given a integer array nums. You're trying to find the triplet where all the numbers are the same, and the distance between the numbers are minimal as well. Okay, so in this example here, you have 2 possible triplets. One is the one with 1s, 1, 2, 3. These are all the same numbers. However, their distance between each other are really far apart, so that's not a good answer. But you also have a 2 and then a 2 here. Their distances between each other are slightly smaller, I guess, than here, so that's a better answer. I understand it now. We can literally iterate like brute force between all triplets. So I go that way, J go that way, K go that way. And then every time we see like I, J, K equal to each other, we can compute the distances of their indices and then add them up. And then we should also track the sort of the min distance between triplets are good. And then every time we see a better one, we update our best. For I in range lane of nums, for J in range start at I, lane nums, and then for K in range J, I just realized that this has to be I plus 1, and we can't use the same index, and then J plus 1, all the way up to lane nums. If all the numbers are the same, if nums I is equal to num J, and nums J is equal to nums K, we also need to track the best min distance. So min distance is equal to, let's do float infinity for now. Wait, I should calculate the current distance first. So current distance is equal to, and I think they literally gave us the formula here. Can I just copy this? Is this valid Python? I hope so. And then the min distance is equal to the min of the current distance, min distance versus the current distance. And then at the end, you return min distance if the min distance is not equal to infinity, meaning we actually found a valid triplet, else we return -1. Let's run this thing. Okay, output is 6, very good. 2 is 8, very good. 3 is -1, -1, very good. Let's this thing. Hey, let's go! We may be late, but we still got one problem. I have 22 minutes to do the last problem. Oh great, this is a sequel, isn't it? Question 2, minimum distance between 3 equal elements 2. The problem looks exactly the same. Let me guess, the constraints? Yeah, the constraints are huge this time. No, we actually have to do it this time the proper way. Okay, question 3, maximum path score in a grid. So in this problem, you're given a grid. In this case, it's like a 4x4 one, but it could vary in dimension. This one is like, I think 0, 1, 2, 0. Apparently you start on the top left corner over here, and your goal is to get to the bottom right corner here. It's like a game board. So over here it says, stepping on a square with 0 on it adds 0 to your score and costs 0. Stepping on a square with 1 with it adds 1 to your score and costs 1. Stepping on a square with 2 on it adds 2 to your score, but costs just 1. And then you're also given a K, which is your cost limit. So your goal is to maximize your score while getting to the n square, while trying not to exceed your cost K. I sent some sort of DFS here. You can literally try every single path, can't you? So start from the top, try every path you can go while keeping track of your current cost, I guess. And then if your current cost exceeds K, you just return. And if you're on the last cell, return the score, I guess. So we have to track our max score. Let's instantiate this to float -infinity first, because we need the max. And then we'll do a DFS, starting at 0, comma 0. We're gonna need to implement this helper function later. And then we need to track the current cost, right? So the total cost, right, so far should be 0. And then we return the max score. It's just so hand-wavy. Okay, now the hard part, the DFS. I have 11 minutes to implement this, oh my goodness. Define the DFS, which will take our current row, column, and current cost. Oh, we also have to track our score, don't we? No, score, which will all begin with 0, I guess. We can only move right or down, right? That makes our life easier. We can first do an out of bounds check, right? So if the row, well, let's just have m equal to, for convenience, length of the grid, n is equal to length of grid first row. So row is greater than or equal to m, or the column is greater than or equal to n, then we just return. And then we also have to watch out for cost. So if cost is greater than k, then also return. And then else, we can do DFS on the next possible squares, right? So we can move right. So that will be DFS row. Right is column plus 1, input the current cost, input the current score, and then DFS row plus 1, column with the current cost, current score. And then now we have to do the actual work of the current square. Up here, let's get the value of the current square. Value is equal to the grid with the row, column. Let's update the score. Score equals the value. And then the cost plus equals the current value, but we also cap it to 1, right? Yeah, so max or min of the current value or 1. Okay, maybe we should move the cost down here, no? If stepping on this square exceeds the cost, then we shouldn't go here, right? If cost is greater than k, then return. Yeah, that's the move, right? We should also probably do a check here. So if we're actually on the last square, if row is equal to n minus 1 and column is equal to n minus 1, then that means we're on the last square. And then max score is equal to the max of the current max score and the current score. Yeah, we should only do this if we're only on the last square. And then if you're not on the last square, then you can, travel to your children and then return max score at the end. I feel like this is a valid strat, no? Cannot access local variable max score when it is not associated with a value. What? We can't access that? Max score? Why? I feel like this is totally legal, no? Python update outside variable from inner function. Non-local? Oh, non-local? You need a non-local thing? Is that how it works? I never knew this existed. What? Non-local max score. Did we get it? Output is 2. Output is null. Oh, max score with 3 minutes left. Oh no. If max score is not equal to negative infinity, else negative 1, else negative 1, negative 1, 2, 2. 2 minutes left. Let's submit this. Please, work. Oh my goodness. Oh no, it's taking forever. I don't like how long this is taking. There has to be a problem, right? No, time limit exceeded. Okay, that's really bad. No. I have 2 minutes to solve this. Hurrah. Can we use this test case? No, I'm so screwed. Oh no, I have 1 minute left. Could I memorize this? Maybe? Like at cache. Oh, submit. 6 seconds left. Please. Come on. No. No. It's because... No. No. It's because of the printing. The stupid printing. No. Oh. Never mind. I still wouldn't have gotten it. Wait. Don't tell me we could have done an LRU cache for this. LRU underscore cache. Dang it. I feel like I would have been able to complete this if I had just like 1 more minute. Dang it. That really sucks, man. No. Time limit exceeded. What if we do the old trick of 4,000? Time limit exceeded, okay. Double it and give it to the next person. Oh. Okay, I give up. I think it's the last cost for this one. Let's see what other people are doing. I'm so curious. I am ranked 17,000. Fantastic. Dang, everyone struggled. Oh my goodness. How did people do? Oh my goodness. It's so simple. Question number 2. What are they doing for them? Okay, I took a peek at the solutions, other people's solutions. I think I understand how this works now. Let's look at this example here. So it is possible apparently to do this all in one go in open time. So what you would do is iterate left to right in this array, and for every single number, you would store basically the last 2 places where you saw that number. Because the last 2 places are the most useful to you. They're like the positions that are the closest to your current number. So for example, for this number, you would first point 1 to like index 0, right? And then the next time you see this one, you'll be like, oh, there's also another one at index 1. And then you see a 2, like, okay, 2 exists at index 2. 3 exists at index 3. You see another 2 here. Oh, there's a 2 at 4. Oh, I see another 1. And then you're like, oh, I've seen 2 ones before. At 0, 1, we can calculate the distances between them and then save the current max distance or minimum min distance. Yeah. And then once you get to the 2 over here, you're like, oh, I've seen 2 2s before. 2, 4. And then my current index of, where are we now? 6, 0, 1, 2, 3, 4, 5, yeah. And then you would calculate the distances between them and then update the min distance. What happens if you see another 1 here though? How would you pop these out? Would this be like a queue, first in, first out, or but backwards? Yeah, you probably pop the first one out, right? And then add in the next one inside, append it to the end. I see, I see. We have a dictionary called last seen at, which is an empty dictionary for now. And then we'll do for I in range of the length of nums. So the current number is equal to nums I. Yeah, so if the current number is not in the dictionary of last seen at, then we have to initialize its entry in there. So maybe we'll put some bogus values in there first. So we don't have to worry about, oh, what if our dictionary just contains one number or zero numbers at first? So we'll do last seen at, the current number is equal to, let's do a list of just -1, -1. Yeah, to update the numbers, we should pop the first one, right? Last seen at n dot pop the one at 0, and then append the current position at the end. Last seen at n dot append the current index. And then else, if we have seen it before, else, yeah, we have to check if we can even calculate the min distance, right? If we have seen it at least twice in the past. If -1 not in last seen at our entry for n, that means we have a distance to compute now. So we should track our best distance up here. Best distance is equal to, let's say, float infinity for now. So the best distance is now equal to the min of the current best distance and the current distance. And the current distance being, oh, they give us a formula here, right? But we don't have k and j defined. So maybe j is equal to last seen at the entry, the first number here, and then k is equal to the first number here. Yeah, and then best distance is equal to the min of the current best distance and your current distance. And then regardless, you update your last seen dictionary. And then at the end, you would return best distance. Cannot access local variable last seen at. Oh, hold on. It's supposed to be an equal sign here. Oh, looks like we're close. We missed the null case, where there's no solution. Return best distance if best distance is not equal to infinity, float -infinity, or just positive infinity, then else -1. Submit. There we go, submit this boy. Hey, let's go. Too bad we couldn't do this in the contest. Okay, let's go to question 3. So why doesn't my thing work? Is it because I have score over here too? Should I have kept track of score not in the parameters, but instead as a return value maybe? I think this function signature is messing up our caching, right? Because now we have to keep track of score in the cache, which is going to decrease the probability that we hit all 4 of these values in the cache, right? Score might not even be the most optimal. So maybe we can not do the score here. Oh ho ho ho. Please, work. Leetcode. Hey! Finally. Dang it. I feel like I could have gotten 2 right. At least 2 right if I had arrived on time during the contest. It's because freaking daylight savings.